Hello, Algebra 1 students, and welcome to the first video of Topic 8 on quadratic functions, and we are doing Lesson 8.1 on the key features of a quadratic function. So let's talk about this word quadratic means, okay? So we talked about quadratics back in the polynomial chapter, right? When we talked about naming polynomials. So quadratic means the highest power of x is the second power, x squared. So all of these functions will have x squared with them. And then just remember the fancy word function, right? Again, it just means we're going to use this notation, f of x. Remember that f of x is just the same thing as saying y. Okay, so don't let the big words scare you. Now again, we're going to talk about the key features of a quadratic function in this lesson. So this is kind of the building block lesson for your quadratic function. So very important lesson here. Okay, so what is a quadratic parent function and what are its characteristics? Okay, so again, the quadratic parent function, the plainest quadratic function in the land is f of x equals x squared. So let's talk about what some of the points are. So I'm going to make an xy table here. So here's my x. I'll make my y a little bit bigger. And again, my y is just my f of x. And then I'm going to put the ordered pairs right here. So then the xy pairs, x, y. Okay, so we're going to use the 5 x values of -2, -1, 0, 1, and 2. That's pretty much your basic starting 5. Okay, so I'm going to take these x values and plug them in for x. So I'm going to plug them in right here in for this x. So it's going to be in parentheses -2 and then the squareds on the outside. Well, when you square negative, it becomes positive because that's really -2 times -2, and that's +4. So one of your points is -2, 4. When I plug in -1, when you square -1, you get +1. So another point is -1, 1. When you plug in 0, 0 squared is just 0. So 0, 0 is on your graph. When you plug in 1, 1 squared is 1. So 1, 1 is on your graph. Notice the connection here with the same y values. And then when you plug in 2, 2 squared is 4. So 2, 4 is on your graph. And again, notice the similarities here with the y values. So I'm going to graph these 5 points. So -2, 4, right there. And then -1, 1, 0, 0, 1, 1, and then 2, 4. And I'm going to connect it with what's called a parabola. So a parabola is this curve. Now again, the way that I like to do is I start at this point right here, like with the turning point, and I kind of go up as best I can, and then on the left side just try to mirror that. And again, it's hard to write this curve. I do my best. I think that's pretty good actually. So there we go. So now, if I take a look at this, so what are some other characteristics, right? So this turning point that I just mentioned, we call that the vertex. So this point right there is called the vertex. It's the turning point. Now for your parent function, the vertex is going to be that point 0, 0. Okay, next, there's this idea of symmetry. Notice, when I said these points are similar, they're y values. So that creates a symmetry where if I split this parabola in half with a vertical line through the vertex, the left and right side are identical. So I'm going to draw a dashed vertical line down through the vertex. We call this the axis of symmetry. Axis of symmetry. All parabolas have it. And it's going to go through the vertex, always and forever. It always goes through that vertex point. Now, vertical lines have equations x equals. So for this vertical line, because the x of the vertex is 0, this equation is x equals 0. That is your axis of symmetry for the parent function. It goes right down through the middle. And again, the idea is that this point over here is the same as this point over here. And that works for all the points going up the right and left side. There's symmetry. Okay. And then 2 more things. Let's talk about domain and range. So the domain are going to be the x values. And again, if I see arrows on the left, an arrow on the right. So this arrow is on the left, this arrow is on the right. That means your domain is all real numbers. There's no x value cannot be, so all real numbers. Now the range, on the other hand, has a definite, or not a definite range, but it has a range in one direction because both of these arrows are going up in this case, up and up. So because they're both going up, that means that this y value right there is a minimum. That is the smallest value you can be. That's a huge deal. So your vertex can act as a minimum, or your vertex can act as a maximum, and we'll talk about the differences going forward. But that minimum y value is 0. So because this parabola opens up, our range is y is greater than or equal to 0. And again, equal to because it can be 0. So it's going to be one direction. Not to be confused with the boy band, One Direction. Okay, and then last but not least, let's talk about this new idea. And I think we talked a little bit about it with exponentials of increasing and decreasing. So increasing and then decreasing. Decreasing. Okay. So the question is, as our graph goes from left to right, are our y's going up or down? If they're going up, we're increasing. If they're going down, we're decreasing. So I'm going to trace my parabola in pink. So if I start right here and I go towards the left and I trace the red parabola, I am going down until I get to that vertex. So this graph is decreasing on the left side. Now, when we put our interval of increasing or decreasing, it's the x values. So again, if this vertex has a point 0, 0, then all of the x's to the left are less than 0. X less. So that is when this graph is decreasing on this side. But now if you pick back up at the vertex and you go to the right, now we are going up. My y's are increasing. So on the right-hand side, when x is greater than 0, that's when your y's are increasing. So they want to talk about when it's increasing or decreasing as well. It would be to your advantage to try to memorize this parent function, right? These 5 ordered pairs. And again, if you just memorize 0, 0, 1, 1, 2, 4, and then just mirror it across the axis, that'd be just fine. Very important idea here. Okay. All right, next slide. Okay, now, I don't know if you remember, right? Oh, it says, how does the sine of a affect the graph of ax squared? We're going to talk about more than just the sine, all right? But I copied it from the book. So we are focused on this a value that goes in front of the x squared. Now, I know last chapter we were so focused on x squared plus bx plus c. We wanted that x squared. But now we're going to have to work with an a value. And this a value does a couple things. All right? Now, to explain what it does, I'm going to take a look at this kind of similar image in Desmos, Ohio. So let me take you there. So we're going to explain this this graph on Desmos, Ohio. So right now, I have f of x equals x squared. It's red. If I turn the blue off, there it is. And now I have g of x equals ax squared. So I have this a in front. And I added this slider. This slider means I can make a whatever value I want to. Okay? So as long as a is positive, so, sorry. Let me make it a little thinner. So as long as a is positive, which means a is greater than 0, your parabola is going to open up. So what I'm going to do is I'm going to slide this slider to the right towards positive 10. And notice my blue graph is always opening up. Always opening up. Okay, let's get back to 1. Okay, now, if a is negative, which means a is less than 0, you're going to see that my parabola is going to turn down. So there's 0. And look, negative numbers, notice the blue one is down. Now, a couple things, right? So in the geometry world, we call this a reflection across the x-axis. So reflect, let me move this thing real fast, sorry. It gets in the way. So this, when A is negative, you are reflecting over the x-axis. So again, that's the geometry teacher me, I apologize. Right? Now, when your graph opens up, we talked about the vertex is a minimum value. But when your graph opens down, now your vertex is a maximum value. This is the highest y value can be, and everything else is going to be lower. Okay, so there's positive or negative. Now, let's talk about the actual numerical value. Let's forget about the sign. So let's just stick with when it's positive right now. So if I take a look at my slider and I move it back to 1. Okay, all right, so there's 1. Okay, so now, if I increase the value of A, meaning it becomes greater than 1, notice what happens to the blue graph. Notice how it gets skinnier. See that? It gets inside the red. What we call that is we call that a stretch. Okay? So if, I'll do this in blue, if your A value is greater than 1, okay, this thing is going to get narrower, or we call that a vertical, we call this a vertical stretch. It elongates. So again, just trying to tie in some words you might have heard in the past or that you'll see in the future. Okay, now I'm going to reset my slider back to 1. Now, if I stay positive but I go less than 1, now look what happens. My blue graph is now wider. So now, if A is less than 1, your graph gets wider, and we call that a vertical shrink or compress. I'm going to say vertical shrink. For us, we will use the words wider or narrower. So wider or narrower or wider. Okay, so again, A positive up, A negative down. A greater than 1 narrow, A less than 1 wider. 4 things you have to remember. Okay. All right, I'm going to stop this video now. There's a second video coming up. Please stay tuned.